How are you everybody? How are you today? This is the 9th lecture in our course Elementary Survey Sampling for third year Statistic English section Bani Harvest 2020. This is lecture is very important and it's related to stratified random sample calculating the population estimation proportion, and I want from every student to study this lecture very closely and know how we can estimate the population proportion under stratified random sample, as we stated in the previous lecture how we can calculate population mean and the population total under stratified random sample. You can go now to section 5.6 estimation of population proportion. As we stated, we focus on in our course elementary sample survey and simple random sample and stratified random sample and systematic random sample and cluster random sample, how we can estimate the population parameter. We estimate in the previous lecture population mean and the population total related to stratified random sample, and now we want to estimate a population proportion to related to stratified random sample. In our numerical examples, we have been interested in examining the average or the total number of hours per week spent watching television. In contrast, suppose that the advertising firm wants to estimate the population fraction of households that watches a particular show. The population is divided into strata, just as before, and a simple random sample is taken from each strata. Interviews are then conducted to determine the population proportion denoted by or abbreviated by BI hat of households in stratum I that view the show or view the television. This B hat I is an unbiased estimator for BI, the population proportion in stratum I as described in chapter 4. Reasoning as we did in section 5.3, we conclude that NIB hat I is an unbiased estimator of the total number of households in stratum I that view this particular show television. Hence N1 B1 hat plus N2 B hat 2 plus dot 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 plus N capital L B hat L is a good estimator of the total number of viewing household and the population. Dividing this quantity by capital N, the grand capital N, we obtain an unbiased estimator of the population proportion B of households viewing the show or viewing the television. Now this is the box about the main important equation to estimator of the population proportion B. B hat stratum, not B hat A as in simple random sample. B hat stratum because it is related to stratified random sample equal 1 over N capital, the grand capital N multiplied by summation N sub I multiplied by B hat sub I. This is equation 5.13 in stratified random sample. Is very important equation. Estimated variance of B hat stratum population proportion equal 1 over n square multiplied by ni square multiplied by 1 minus n small I over n capital I multiplied by B hat Q hat over ni minus B. You must know that if there is no any information, prior information about B hat and Q hat, B hat and Q hat must be equal 0.5 because B hat plus Q hat equal 1 as we stated in simple random sample. B hat plus Q hat equal 1. Now also B hat in stratified random sample plus Q hat in stratified random sample must be equal 1 or 0.5 and 0.5. Example 5.12, the advertising firm wants to estimate the population proportion of households in the county of the example 5.1 that view show X television. The county is divided into strata, town A, town B, and rural area. The stratum contains any capital 1 150, any capital 2 62, any capital 3 93 households respectively. A stratified random sample of n small grand n small equal 40 households in chosen with proportional allocation. In other words, simple random sample is taken from each stratum. The sizes of the sample n small n equal 20, n small 2 equal 8, n small 3 equal 12. Interviews are conducted in Table 5.8 data from example 5.12 stratum 1 2 3 sample sizes small n1 equal 20, n2 equal 8, n3 equal 12. Number of households viewing show X or television 16 to 6. B hat equal 0.8, 0.25, 0.50. The 40 sample households results are shown in table 513. Estimate the population households viewing the shown X and place a bound on their estimation. Solution: the estimate of the population household viewing show X is given by B hat strata using equation 513. This is a direct application and direct substitution to calculate B hat strata equal a direct substitution, direct application 1 over 310. This is the grand in capital multiplied by 100, 50, 50 multiplied by 0.8 plus 62 multiplied by 0.25, 93 multiplied by 0.5 equal 0.6. This is the population proportion related to stratified random sample in our example. So the variance of B hat strata variance for each stratum variance hat B1 hat variance B hat 2 variance B hat 3, so that we calculate variance for each stratum V hat B hat 1, V hat B hat 2, V hat B hat 3. This is a direct substitution, direct application to calculate the variance for each stratum. It's very important to know, and you must study. I want from every student to study this slide very closely related to calculate variance for each stratum in population proportion. V hat B hat 1 equal 0.007, V hat B hat 2 equal 0.024, V hat B hat 3 equal in the next slide. V hat B hat 3 equal 0.020. From equation 5.4, V hat B hat strata for all strata. This is the variance for all strata equal 1 over n square multiplied by n I square. V hat B hat I, so that equal 0.0042. Then the estimated population proportion of households in the counties that view X show or showing X with a bound on their estimation is given by B hat strata. This is a confidence interval B hat strata plus or minus the bound on their estimation equal 2 multiplied by V hat B hat strata equal 0.6 plus or minus 0.13. The bound on their estimation in example 5.12 is quite large. We would reduce this and make the estimator more precise by increasing the sample size. The problem of choosing a sample size is considered in the next section. How are you everybody? How are you today? This is a 9 lecture in our course Elementary Survey Sampling for third year Statistic English section. This is lecture is very important and it's related to stratified random sample calculating the population estimation proportion, and I want from every student to study this lecture very closely and know how we can estimate the population proportion under stratified random sample, as we stated in the previous lecture how we can calculate population mean and the population total under stratified random sample. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.